So now we're going to have a look at our last set of goodness of fit tests, which is for the rectangular or uniform distribution. Now these are slightly different from each other. The uniform is a bit more like a specified distribution, whereas the rectangular one is slightly different. Remember that uniform is usually used on discrete data and rectangular is for continuous data. Here we care about the number of observations that we have and the number of groups that we have. So we're going to do the number of groups after pooling minus 2 for our degrees of freedom. And all we're going to do is make it so that we have the same expected value for each of our outcomes. So our H0 is going to be that the uniform model is a good fit because we're rolling an octagonal dice, which means that we'd hope that if the dice was not biased, that we would have the same number of outcomes for each of the numbers. So here we need to add up how many of our observations we have. 7 plus 10 plus 11 plus 9 plus 12 plus 10 plus 14 plus 7. Just double checking that I've typed all those in correctly, and I have, which gives me 80. I have 80 divided by my 8 groups, which means that for each of them my expected value is going to be 10. So we're going to have our outcomes 1, 2, 3, 4, 5, 6, 7, 8. We're going to have our observed values 7, 10, 11, 9, 12, 10, 14 and 7. And our expected value is just going to be 10, 10, 10, 10, 10, 10, 10 and 10. So then in our statistics part, in our first list, we're going to put our observed values. So 7, 10, 11, 9, 12, 10, 14 and 7. And then for our list 2, each of these is going to be 10. And 10. Test, chi, goodness of fit. None of our expected values are less than 5, sorry. So our degrees of freedom is going to be 8 minus 2, which gives us 6. Yes, I put my observed into list 1 and my expected into list 2. And that gives me a chi-squared value of 4, which is my test statistic. My critical value from my formula booklet, page 20, doesn't say what significance level to use, so we use 5%, which means we're looking from 0.95 across from 4, across from 6, which gives me 12.592. So then as the test statistic is smaller than the critical value, we're going to accept H0 at a 5% significance level. There is insufficient evidence to suggest the uniform model is not a good fit. Now, the difference between that and a rectangular model. So here we have a rectangular question. We have A recently built office block has suffered a large number of false fire alarms during office hours between 8 and 5, and we're trying to see if the rectangular distribution can be used to model this. Now, first of all, if you think about what our rectangular distribution looks like, and we're looking at between 8 a.m. and 5 p.m, it will probably help us to actually think of it in terms of a 24-hour clock, so 0800 and 1700, because then we know the width of our rectangle. Okay, we've got 9 hours between 8 a.m. and 5 p.m, which means that the probability of the side here is going to be 1 over 9, because remember that the area of the rectangle is going to be 1, because all probabilities are going to add up to 1. So then if we're looking at the probability, if we first just copy our intervals, so between 8 and 11, 11 and 1, 1 and 3, and 3 and 5. For our observed, we have 19, 3, 6 and 7. And then for the probabilities, well, our width between 11 and 8 is 3. 3 times 1 over 9 is a third. Between 11 and 1, that's like saying 11 and 13, we're going to have a width of 2. So that's going to be 2 over 9. And then between 1 and 3, that's like saying between 13 and 15. Again, we've got a width of 2, which is going to be 2 over 9. And lastly, between 3 and 5, that's like saying between 15 and 17. That's going to be another 2 over 9. And 2 and 2 and 2 and 3 does add up to 9. So I've got all my probabilities. So then to get our expected outcomes, we need to times by the number of observations that we have. We're not told how many there are, so we're going to have to add our observed values together, which is 19, 3, 19 plus 3 plus 6 plus 7, which gives us 35. So we're going to times each of these by 35 to find our expected outcomes. So we're going to have a third times 35, which gives us 11.6 recurring. I am going to keep that as a fraction as well. It's 35 over 3. The only reason why I changed it to a decimal was to check that it was greater than 5. Next, we're going to have 2 over 9 times 35, which gives us 7.7 recurring. And again, just so I've got the accuracy there, I'm going to keep that as a fraction for now. So that's 70 over 9. And the other two are the same. Just having a look at the decimal version to check that it was more than 5. So then we're going back into our graphical calculator. Delete anything that you already have in there. Remember that that third column has been filled out with our contributions, so that's why that got filled out automatically. So in our first list, we're going to have 19, 3, 6 and 7. And in our second list, we're going to have 35 over 3, 70 over 9, 70 over 9, 70 over 9, like that. Test, chi, goodness of fit. This time our degrees of freedom is going to be 4 minus 2, which gives us 2. And that gives us our test statistic. Notice here, I haven't put my H0 and H1 yet. Oops. So my H0 would have been that the rectangular this time model is a good fit. H1, the rectangular model is not a good fit, because this time it is continuous, not discrete. So this time it's rectangular, not uniform. So my chi-squared value from my calculator is 8.03. That's my test statistic. My critical value from page 20. This time we're told to use 10% significance level. So we're going down from 0.9 and across from 2, which gives us 4.605. So as the test statistic is bigger than the critical value, this time we're going to reject H0 at a 10% significance level this time. There is sufficient evidence to suggest the rectangular model is not a good fit. And if we have a look at the values that we started off with, it was quite obvious because we had quite a lot between 8 and 11 and not so many closer to the end of the day. My strongest suggestion with the rectangular one over a uniform one. Uniform ones are nice and easy. Just add up your observations, divide by the number of groups that you have. With the rectangular ones, I always suggest draw a diagram. Have a look at what your rectangular model looks like. It helps you to find the width. It helps you to find the height. And then it helps to imagine what you have in terms of the areas for each of your intervals. So just to go over this bit again, how I got the third, the 2/9, the 2/9 and the 2/9. The first one, we're looking at between 8 and 11. So that had a width of 3 and a height of 1/9. Next, we were looking at between 11 and 1. Remember that 1 o'clock in terms of the 24-hour clock is 13. So that had a width of 2 and a height of 1/9. Next, we were looking up to between 1 and 3. 3 o'clock would be 1500 hours, which again has a width of 2. And lastly, we're looking between 3 and 5, which again has a width of 2 and a height of 1/9. So that's how I found each of those probabilities. Thank you very much for listening.